Hi, my name is George Garcia. I'm a product support specialist at Autodesk EAGLE, and in this video we're going to take things back to basics. We're going to learn about the properties of through-hole pads in the library so that we can better leverage them in our design. So I'm going to go ahead and open up this component that consists strictly of through-hole pads, and we're going to analyze its properties by using the info command. So I'll use the I for info, click on the pad. Now if you notice, there's not too many parameters. The name, remember that for footprints we generally stick to numbers. There are occasions where you may want to use something different, but typically for footprints we stick to numbers because these numbers make it easier to then associate the pad to its function when you're doing the device. Position, also self-explanatory. The first rectangle, the first field is the x coordinate. The second one is the y coordinate. Angle is basically the rotation of the pad. We measure rotation, if you imagine a circle, 0 degrees is at 3 o'clock, and then you move counterclockwise around the circle from there. Okay, so if we have angle here, we go 90. If I hit apply, it rotates. And we can keep going around that way. So I'll put it back at 0. The mirror option moves the pad from the top to the bottom. In the case of a through-hole pad, visually you're not going to notice much difference. In general, in the library, we do not use the mirror option. All parts should be drawn as if they were placed on the top of the board, because when you use the part on the board, you can always use the mirror command to flip it and all the layers automatically adjust as needed. So usually in the library, you won't be using the mirror option. Now, diameter warrants some explanation. If you notice, we have this value of auto. If diameter is set to auto, that basically is EAGLE telling you're basically telling EAGLE that you're going to let the design rules dictate what the overall diameter of the pad should be based on the annular ring settings in the DRC. Now, if you specify a diameter, this value is not set in stone. It's still subject to being overwritten by the design rules in the board. What ends up happening is that EAGLE will compare the diameter value that you have specified to what the design rule calculates using the annular ring settings. The larger of the two is going to win. So if you have small annular rings or very thin annular rings, what you will probably find is that when you use the part, the rings will swell. And it's because of that, because the design rules are set in such a way that they've turned out to be larger than the diameter you specified. At that point, you would go into the design rules, annular ring tab, and make adjustments. We'll leave it here on auto for now. Drill value is easy. Drill value is the actual hole diameter. This value is immutable. It's not subject to discussion with the design rules in any way. So whatever you set here, that's what you're going to see. Shape is the different geometries that we support in EAGLE. In the library, we have 5 geometries we support. You have square, you have round, you have octagon, you have long, and you have offset. And these use depending on what the needs are of the component. Lastly, we want to talk about these 3 checkboxes. We have thermals, we have stop, and first. If thermals is checked, that means that this pad accepts thermal connections from a polygon in a design. So as you know, when a polygon fills, any pads that connect to it generally want to be connected through a thermal connection. You don't want a complete connection to the copper, because what ends up happening is that all that copper is going to sink heat away from the soldering iron, and that can lead to cold joints. So having this option checked by default guarantees that you get a thermal connection, and that allows heat to build up, and you can get a good solder joint. Stop is basically this little outline here. This is a stop mask opening. This basically guarantees that the pads will be exposed on the finished PCB. If you uncheck it, you'll see that that goes away. If left like this, what's going to happen is that that pad is going to be covered with stop mask, with the green stuff that makes PCBs green. What you generally want to do if you uncheck this box is draw your own. That's usually the only reason that you uncheck the stop box, is if you have a certain component that requires kind of a specialized stop mask opening, then you would uncheck the stop checkbox. Now first is interesting. First basically adds another layer of control to the design rules. If you check this checkbox on a pad, you're saying that this pad is the first pad of the component. And what this allows you to do is at the board level, you can go into the DRC, to the design rules, and say that all of the first pads should have a certain pad shape. So right now we have these three longs over here. If I have this one set as first, what would happen is I could change that to be circular, and that would make it really easy to see orientation on a PCB. So that's one option. Most users that want to somehow distinguish on a through hole part, what they'll do is they'll either draw it on the silk screen, or they'll very explicitly change the shape here in the library. That way it can't be tampered with by the design rules. So those are all ways to achieve the same thing, and that's an option that users have when working with through hole pads. So this covers all of the properties of through hole pads. Thank you very much for joining us in this video. We'll see you next time.